Okay, the next set of notes is for what is called slope fields. Um, Slope fields are going to be something you graph, and I have a few examples down here of some slope fields. And what I want you to notice is they kind of remind me of like meteorology maps. But what they are is they're little tick marks that represent the slope at that coordinate. Okay? Um, so this one kind of looks like it's an equation with maybe both x and y in it because I noticed that like the slopes change for different x values, whereas you look over here at -5, the slope is the same for all the different y values, and here it's the same. So slope fields are a representation. Oh, need a pen. Oh my goodness. Representation of differential equations. You remember writing those? Okay, so they are like allowing you, so when you wrote a differential equation, you often had a C value, okay? So slope fields are going to kind of allow you to find C, okay? So let's dive into this. So what the examples would look like is they'd say, construct a slope field for the differential equation dy dx equals cosine of x. Okay, so we're going to draw a slope field for that. So since this is a trig function, I am going to put like pi over 2, pi, 3 pi over 2. Let's also do, let's also do negative pi over 2. Maybe. Okay, so what we're going to do is we're going to pick these inputs and plug them into the equations for the derivative. Remember, derivative represents slope. Okay, so when I plug in pi over 2 and I do, okay, so I'll write it all out this time. Dy dx equals cosine of pi over 2. Well, cosine at pi over 2 is equal to, that's up the 90 degrees. The x value there is 0. Okay, so back to these little slope fields. These slope fields, again, are just like a little tick mark that represent the slope at that x and y value. So for example, you see these horizontal lines? That means that there's a 0 slope at all those different coordinates. Okay, and then you see these are like really positive right here. That means there's a very positive slope. These are very negative. Okay, so back to this one. When x is pi over 2, I have a 0 slope. So what I'm going to do is I'm going to put a 0 slope all along the x value pi over 2. So just like a couple. So I'm doing these horizontal lines because that's what a 0 slope is, right? So horizontal lines at pi over 2. Okay, so let's do another one. How about then cosine of pi? Well, cosine at pi is -1. Okay, so all along pi here, I'm going to draw a slope of -1. So my tick mark just needs to be this little tick mark that looks like it has a slope of -1. Okay, what about at 3 pi over 2? Well, at 3 pi over 2, so 3, the slope is also 0. So I'm going to have this 0 slope again. Okay, what about 0? I kind of skipped 0. What is cosine of 0? 0 radians. At 0 radians, it's positive 1. Okay, so at 0, all along x equals 0, I'm going to be drawing this positive 1, slope of positive 1. Okay, then what about negative pi over 2? That would also be 0. So this slope field is starting to take shape. And then what about after 3 pi over 2 is 2 pi. And cosine at 2 pi is also positive 1. So it goes up like this. Okay, so then a big question I have for you is, what does this slope field look like? Okay, so as you're thinking about that, I mean, I want you to kind of, like if you were to draw a function in there, you know, you kind of start following it and it's got this wave. Okay, it's a definite trig function, right? At 0, 0, it has a slope of 1. So that I hopefully kind of reminds you of sine of x. Yes? Okay, so why would this look like y equals sine equals? Why am I writing the whole word? Why would this equal y equals sine of x? Well, this is the differential equation. Oops, I didn't mean to go there. I meant to go actually all the way up here. This is the differential equation cosine of x. Well, this is the derivative. The derivative equals cosine of x. What is cosine of x the derivative of? Sine of x. Okay, but actually this slope field represents, remember how I was talking about that plus c? This slope field represents no matter what that c value is. Because remember, this could be y equals sine of x plus 7, and the derivative would still be cosine of x. It could be sine of x plus 83, and the derivative of sine of x plus 83 is still cosine of x. It could be y equals sine of x minus 8.3, okay, and so that would be like down here, but this slope field accounts for that. Okay, so I want to do this one because this one is actually kind of like this one where you can see it doesn't have the same, you didn't just draw the same tick mark at -3 like you did here. It looks like here at -3 we have a variety of slopes, and that's because the original equation, the original differential equation, has both x and y in it. Okay, so this one might be a little bit more challenging because we won't just go to a single x value and put the same tick mark all along that x value in that column. Okay, so a few things to kind of keep in mind. First of all, up here, I should have added this, but y cannot be 0. Yes. Okay, so in fact, if y can't be 0 because you can't divide by 0, what if y is 0? Well, why is that an issue? Because y could be 0 on this on this coordinate plane here. I'm going to add a few tick marks. Okay, so if y is 0, as in it's not moving up or down, that means you would have an undefined slope. What does an undefined slope look like? That is a vertical line. So instead of drawing a horizontal line for a 0 slope, all along where y is 0, I am going to put a vertical line. And this gets kind of confusing because I added these tick marks in black. That's just for the grid. But now I'm going to go through and add vertical tangent lines, which is like right over the tick mark for the graph, but these are actually a part of my slope field. Okay, all along where y is 0, meaning you're not up or down, that's all along the x-axis. That means I have a vertical tangent line because it's undefined there. Okay, what happens if x equals 0 then? If x is 0, that's the numerator, that means we have a 0 slope. Which means a horizontal tangent line. Horizontal line. Little tick mark. And again, this is kind of confusing because it ends up just looking like the black tick marks I made. But when x is 0, which is along the y-axis, I have a 0 slope. So it ends up going right over what I made. Okay, so then what we have to do is probably the harder part, which means we just have to start like picking some values and seeing what happens. So like, what if I pick, well, I want to know what's happening at 3, 1. Well, that means dy dx would equal 3 over 1, which would be a slope of 3. So 1, 2, 3 over 1 up, I have a slope of 3. So that's a little bit more slanted than a slope of 1. Okay, let's just pick another one. How about, let's do -1, -2. Well, that would be -1 over -2, which would be 1/2. Okay, so that's not a very slanted slope. -1, -2, so it's positive. Oh, I meant to do green for the slopes. Green. Okay. Okay, so I'm still not getting a very good picture of this. So we're going to have to probably add a few more points before we really start knowing what's going on. But is there anywhere else that you can think of that would be interesting? So that is going to be when x and y are the same. So like at the coordinate 2, 2, when x and y are the exact same, that slope would be 2 over 2, which is 1. So actually everywhere x and y are the same, I have a slope of 1. So at 2, 2, I have a slope of 1, but I actually have a slope of 1 all along where x and y are equal. And like when you have 1, -1, the slope is just going to be -1. So I'm going to add these tick marks everywhere x and y are equal. Okay, so then let's kind of look at how about 1, -2. That'd be 1 over -2. So that would actually be almost like this slope except negative. So you kind of see this, start to see this symmetrical look. Okay, so just to start, like whatever I have here, over here I'm going to have just like this the reflection of that over the y-axis. So these are like fractions. Okay, so that should be the same up here too. This slope was 3, so this one over here is going to be -3. And then actually it would reflect over the x-axis as well. So you can add a bunch of, or you can go through and do a bunch of these, but you can also just kind of start getting a good picture of what this looks like. It's pretty symmetrical, so 1, 2, 1 over 2 is 1/2, and then reflect that. Okay, so it looks like that. Okay, so your homework is kind of a combination of doing, you know, some slope fields that just have x in them, and then others where you have to have both x and y. Those might be a little harder, but this is your homework. You can get started on that today.